So the next load balancing method what we are going to be discussing is what called as predictive. Predictive is also a kind of observed, but the ratio is going to be assigned. But what information it is going to be taking, can you see this one? I'm going to be taking two different states. In each and every state, how many active connections were there? So basically what we are trying to do is we are trying to trend the number of active connections. Right. Point A, these many number of active connections were there. In point B, we were having these many active connections. What is the delta between these two? Right. As the number of connections are being closed, for example, let's say this one. Say server 1, I have at stage number 1 I had 10 connections. In server 2, I had around 15. So in server 3, I had around 5 connections. Let's say like this. This is stage number 1 at one time interval. On the second time interval, I'm seeing this as 12. I'm seeing this guy as 10. I'm seeing this guy as still with 5 connections. Now, what is the difference between the stage 1 or what we call it as point 1 and point 2? This is equivalent to plus 2 connections had been added, right? Here, minus 5. Here, no change. So that means what? Server 1 has been increased with the load, whereas server 2 number of connections has been reduced, so the load is lesser. So based on this, a dynamic ratio value is going to be assigned. As the server 2 has been reduced with number of connections, the ratio is going to be higher. And this is going to be happening dynamically at every interval. So as the connections increases, the ratio decreases. As the connection decreases, the ratio increases. So somehow we are trying to balance the load across multiple servers. So I know that you will be knowing where you have to go and select the predictive. You have predictive member. You also have predictive node. So you can select any of these options as per your requirement. Say OK, and then you can get the results of it. So that's all about your predictive.